The key concept in electromyography, or EMG, is the maximal voluntary contraction. This allows us, it's a unit of measurement that allows us to compare EMG signals between muscles, between people, between studies. Otherwise, it would be very, very difficult for us to make any sense out of this measurement. So, collection conditions can be variable day to day. Even day-to-day measurements of the same muscle in the same lab can vary. Electrode placement can vary slightly. Person to person, obviously muscle contraction can vary. And so the unit that comes out of the device, millivolts, is too variable. So we want to normalize it to something. And what is the standard now is we normalize to maximal voluntary contraction. So we take whatever muscle we're interested in testing, and we have that participant, contract that muscle to their max effort and take that EMG signal as 100%, and everything is in terms of that percentage. Examples of percent MVC are in this table, right? So it's percent of a maximal contraction when you're prone, and it's looking at EMG of the biceps femoris, and it's comparing different exercises. So if we just compared the millivolts, that would not completely be accurate. So we take it as percent of max. And so kettlebell swings seem to have a high level of activation. RDLs seem to have a lower level of activation. So this is a way to compare exercises and muscle activation. Here's another example using the semitendinosus. So you can compare the semitendinosus versus the biceps femoris for different activities. You can see the kettlebell swing is much lower. Oh, actually not too much. You got to look at the units. Pretty high variability for reverse hip raises and stability ball leg curl. But you can see kettlebell swings, glute hams, seated leg curls. Actually, they're all almost hitting 100%. So how do we obtain MVC? A lot of people want to lift a heavy weight. The best way is just manual resistance. So you can see this is going to be elbow extension. So we're going to be trying to get MVC of the triceps brachii. So we're looking at the elbow joint. So this participant is going to be applying an extensor torque to the maximal effort, and the researcher is going to be applying a resistance here, this force times this moment arm, and that will result in a flexor torque. So the flexor torque is being applied to resist this extensor torque, and everything is to the max. And here we see the output. So channel 2 is the triceps, and channel 1 is the biceps brachii. And so you can see during this max contraction, lots of activation from the triceps, minimal from the biceps. And you take this activation as your 100% of max as what you relate all your data collection to. Here, this setup is going to test the MVC of your biceps brachii. So the participant is trying to create a max flexor torque. The researcher is creating an extensor torque to elicit that max flexion torque, which will elicit the max muscle activation of the biceps brachii. And here we see that the biceps brachii has a max activation, minimal activation out of the triceps. So this would be our 100% for biceps brachii.